Hello, this is Looking Forward for Physics 200 for Wednesday, the 27th of February, 2019. As you get ready for class on Wednesday, I'd like you to read through sections 4.1 and 4.2, 4.4, and 4.7 of your book, and think about the following questions. First, in thinking about your questions, from 4.1 and 4.2, are you comfortable that particles, or at least things we normally think of as particles, electrons, neutrons, etc., can have wave properties? Second of all, thinking about stuff, are you comfortable with things like the frequency and wave number of waves? That you know what they are and how they relate to, let's say, angular frequency and wavelength. Second of all, I'd like you to think about Fourier series from Physics 201. And in particular, as you think about them, what I'd like you to think about is some function that you're going to try to describe. There's my function as f, let's say of t, here is a function of time. Now let's compare it, let's say, to a different function here. Now if we think about those functions and we think about the Fourier series we need, how do the frequencies needed how do they compare for this broad function in comparison to this narrow function? In other words, as I get functions that are sharper and sharper and sharper, do I find that the frequencies I need are different in some way than for functions that are very, very broad, or even finally in the limit, pure sinusoids? Another way to put this is, if you were to plot the Fourier A's or B's as a function of frequency, would you find that you would need a different width or different spread in the number of those frequencies that you needed? And so based upon that, does there exist a relationship between the spread in time for a function and the spread in frequency for its spectrum? Now, why is that? We'll talk about those things and more when we get together on Wednesday. See you then.